Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this particular video, we're going to be focusing on how you can modify data tables in R. So let's go ahead and see what we can learn. All right, so I'm inside RStudio now, and we're going to be focusing on modifying data tables. So when we're talking about modifying, we're talking about adding columns, calculating various values, removing values. Those are things we've talked about in the past, et cetera, et cetera. So that's what we're going to be doing here. So first we need to load our libraries, packages, and create our object that we're going to manipulate. So in lines 1 and 2, we load the library data.table, and we're going to use the dataset mtcars. This is loaded by default into R. It's already available once you install RStudio or the R language. And we're going to convert that object to a data.table. That's what we're going to do in these first two lines. So that's done. Now we can start playing with it. The first thing we're going to do is add a new column. But let me show you what it looks like first, just to give you an idea in case you're not familiar with this particular. So you can see right here that we have about 9 variables here, 9 columns, and we're looking at the first 6 values. So mtcar gives you miles per gallon for a car, number of cylinders, the displacement, horsepower, the drat, the weight, Cusack, VS, whether it's an automatic transmission or not, AM, the number of gears, and the size of the carburetor. So that is what this particular data set tells you. Now what we're going to do is we're going to calculate a new value. We're going to create a new column. This is something you do in lots of different ways. I guess you can call it a calculated field in Power BI, whatever you want to call it. So what we're doing here is we're making a new column called distance travel. And so what we're doing here is we're going to take MPG and multiply it by 4. Let's say someone drives for 4 hours as an example. Now notice the syntax here. We start by, our data set. Then we have these square brackets. Inside the square brackets, we start with a comma here. Normally to the left of the comma has something to do with rows. It can also be for like filtering. And normally to the right of it, you are given the name of a new variable. So this is going to be a new column called distance travel. Then we have this colon equal sign notation. And that everything to the right of that is like, okay, the actual calculated field that you're going to be doing. So we're going to take the column miles per gallon and we're going to multiply it by 4. That's what this asterisk times 4 right here is. So when I do this, you see everything is good. Let's take a peek. And so now you can see there's a new column right here to the far right, distance travel. And it's just the value of miles per gallon times 4 for each of the 6 rows here. That's all we're doing here. A very, very simple, basic calculated field. Now, sometimes we make mistakes, or there are mistakes in the data, and I'm going to show you how to deal with that. So in lines 8 and 9 here, this is what we're doing. We are telling R, let me back up. Let's just say, for example, that any column or any row that has the value 21.5 or less in miles per gallon is a mistake. We're going to classify that as a mistake for this example. So what I'm telling R is this. For miles per gallon or MPG, if it's less than 21.5, so this is kind of like my filter rule right here. And then to the right of the comma, I'm saying set miles per gallon to NA, or not available, or no value, or whatever. And so what's going to happen now is that R will go through every single value of MPG. And when it's less than 21.5, it will replace that value with NA. So, for example, in our output down here at the bottom, looks like rows 1, 2, 4, 5, and 6 will be replaced once we run this. All right. We take a look at the head again, and you can see right there, rows 1, 2, 4, 5, and 6 were all replaced with NA values. So this is a way to replace one value with another, if this is what you want to do. Now you can also do the opposite and replace NAs with a value, whatever you want to do. But this is how this can be done. Now, next example. This one's a little bit more complicated. Let's see if we can understand this. All right, so we're going to create a new column equal to the total cars with automatic transmission. So we're trying to count how many cars have an automatic transmission and put that in a new column. So here's what we're doing. There's really no filter here, so there is blank to the left of the comma. To the right of the comma, we're creating a new column called total underscore AM, and then we're going to count those. That's what this dot in means, by whether it has automatic transmission or not. So this is kind of hard to understand, but to make it simple is this. Let's say there's 12 cars with automatic transmission and 10 without. For the cars that have an automatic transmission, you will see a 12 in this new column. And you will see another number if not, as an example. But let's take a look at this. All right, we take a look at the head real quick. All right, here's our new value. So total number of automatic transmissions, 13. So if a car has a 1, that means this car has an automatic transmission, is part of the 13 that do have an automatic transmission. If this column AM has a 0, that means the value over here in my new column will be 19, because there are 19 cars without an automatic transmission. That's what that particular syntax is doing. This is similar to something you would do with like a windowing function in SQL, as an example. Now, we're going to move on. We have about 4 more examples. And before we go to the next example, we have to clear out the object that we're using right now, because the syntax is, or the data set is getting a little complicated, and it'll start messing up my values. So let me just show you how I'll do that. All right. So first, we're going to remove the object empty cars. That'll make this guy over here to the right disappear. Then we're going to run it again, and then we're going to create a new one, a new calculated field. And so what we're doing down here in line 17 and 18 is we're going to calculate the mean miles per gallon. That's what we're going to do by cylinder. So what's the average miles per gallon for 4 cylinders? What's the average miles per gallon for 6 cylinders? And also for 8. So let's go ahead and run this. And then we just take a quick look at the top. All right, so here we go. If a car has 6 cylinders, that's this column right here, then it's going to have an average miles per gallon of 19.74. If it has 4 cylinders, it's going to be about 26, almost 27. And if it has 8 cylinders, it's going to go down to 15. That's what's happening. So it's almost like a group by, again, referring to SQL and calculating the average miles per gallon by cylinder. And so this new column will tell you the average miles per gallon based on how many cylinders that particular car has. And so one more thing I need to mention here is this idea of how you can use a function right here when you're setting up your notation here. So we have the comma, so there's really no filtering this time. This is the name of our new column. And then we use this colon equal sign notation. Here's our function. We're removing if there's any NAs, just for thoroughness. And then we have a comma, then by cylinder, by the column called cylinder. That's what's happening here inside our code. All right. Now there's another type of notation called left-hand side, right-hand side notation. And basically we're going to do the same thing using a different notation. This is not that deep really, but here's what's happening. Notice how we still have nothing to the left of this comma right here. That means there's really no filtering. And so right here, we're creating 2 variables this time. Their names are inside the C function, inside quotation marks, mean underscore MPG, comma, median underscore MPG. We still have our dot equal sign notation here. And then this right here, I hope you can see that there's clearly a dot outside these parentheses right here. And then inside the parentheses, I have 2 functions. One function for each variable that I'm creating. Mean MPG and then median of MPG. And then all this is going to be by cylinder. So we're going to calculate the mean and the median by cylinder for each row of data. So here we go. And then we take a quick look at it. Now you can clearly see we have two new columns here. That's what we have. And so notice how we just kind of overwrote mean underscore. We have it up here in the previous example, and then we have it here, so we just overwrote itself. But we also have the median as well. If you look down here in the output, the console, if you will, it's probably a better term for that. And so now we have these two columns that we just created, all by cylinder. And so that's another way to create additional values. All right, next, we're going to do the same thing with functional form. Again, it's kind of the same basic idea, just using a different type of notation. The type of notation you use depends on your preference and the situation you're facing. But here we go. Now, here we go. We still have things inside brackets. Nothing to the left of this first comma. So that means there's really no filtering going on. Then we have our our colon equal sign, and these things called grave accents. Grave accents, this is the button next to the number 1 above QWERTY on your keyboard. So we're talking about the ones that go across in a row at the top of your keyboard. To the left of that number 1, which also can be the exclamation mark if you set the shift, you have something called grave accents. And so you put the colon equal sign inside grave accents. This is also where you found the tilde button if you hold down the shift key there. And then you set the names of your function, or excuse me, of your column, followed by the actual calculation. So we're calculating mean here. Then use a comma, then the name of your next column, followed by how it's going to be calculated, put a comma, and then by cylinder. So the same thing we did last time using a different notational style. We run that, run it again, and now you can see we got the same values, we just gave them a different name. So mean miles per gallon for a functional form, median miles per gallon functional form, and they're the same. Let me make this bigger. Notice how these are the same value because we use the same functions. That's why they're the same. And so it's another style. It all depends on what's easiest for you and what you're facing. All right, last one. And so this time we're going to have a filter, and we're going to calculate it by multiple conditions this time. So look at what we have here. Let me make this nice and clear. So we're calculating for anything where the miles per gallon is greater than 21. We're going to do the following. Calculate the average miles per gallon using means as our function, of course. And it's going to be by, notice a dot on the outside, the number of cylinders and whether it's an automatic transmission or not. So that's what's going to happen. So it could be 4 cylinders and it has an automatic transmission, 4 cylinders and no automatic transmission, like that. So let's go ahead and run this. And let's see what we got. All right. So here's what we have here. So we have average. Now notice something here. This only works in certain situations. So it works in line 4. So we have 6 cylinders and no automatic transmission. In other words, there has to be more than one of these in order for this to work. If none of them meet this criteria, it's not going to work. So for example, in our first one, we have, in row number 1 here, we have 6 cylinders and we have an automatic transmission. We have 6 cylinders and automatic transmission. But what's the problem? It has to be greater than 21. So that's why we have the NA. Since this is not greater than 21, that's why we have NA down here. If you look at row number 3 is 22.8. That's why we're able to get a value right here. If you look at row number 4, we got 21.4. That's also greater than 21. That's why we have a value here. And the reason this is 21.4, as I was trying to explain this earlier, maybe not so clearly, is there's only one car that has 6 cylinders and no automatic transmission. So this value is the mean, basically. That's what's happening there. And so you can see there's lots of different ways that you can go about dealing with this and calculating things with data.tables. So let's summarize what we learned and wrap up this video. So in this video, what we were focusing on is how to create columns, add columns, and even modify values using data.table. So first we made our data, our object, we converted it to a data.table. First time we just calculated a value, not a big deal. Then we replaced certain values with NA based on our criteria. Right here, we count out the number of cars based on whether they were automatic transmissions or not. That's what this .n does, it just count. After that, we were able to do something a little bit more complicated, calculate the average miles per gallon based on the number of cylinders the car had. The next two examples, we kind of continued this idea, but we learned how to do with left-hand side, right-hand side form, and also functional form. That's what these two are here for. And everybody has their own flavor and preference. Either one will give you the same answers. And then the last example that we did, we were able to calculate the average miles per gallon, filtering for when the car had more than 21 miles per gallon, and also by the number of cylinders and whether it had an automatic transmission or not. So a much more of a complex way of finding values. So this is a way where you can subset, and find very minute, specific details within your data set when you're drilling down like this. So I want to thank you so much for listening and watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you again, and take care.